Hello, welcome to 2H TV, a home where concepts are treated one after the other. In today's tutorial, we are going to look at the periodic properties of elements. We will be looking at 4 in these discussions. We are going to look at atomic radius. We will be looking at ionization energy. We'll be looking at electron affinity. Then the last one for the day will be metallic character. So these are the 4 periodic properties that we are going to look at in this tutorial. So let's look at what atomic radius is. So talking about atomic radius, so atomic radius is simply the distance between the nucleus of an atom to the outermost shell of its valence electron. So let's look at this particular atom. Let's say we have 3 shells. So the first one will take 2. The second one, let's say, is taking 8. So this atom is number 10, right? That will be neon, right? So neon. So let's use let's add one more shell and add 1 electron. So that becomes sodium, Na, right? So atomic radius is simply the distance from the nucleus here, from the nucleus right to the last valence electron. So this is an atomic radius for sodium. Let's look at one other example. Right, so this is the nucleus. Then the first shell will take 2. Let's say the second shell is taking 1. So the atomic radius, the radius is from the nucleus to the outermost valence electron. So you could see that the more the shell, the longer the atomic radius. The less the number of shells, the lesser the atomic radius. So if there are a lot of shells, the atomic radius will be long. If the shells are just little, the atomic radius would be little, or it will be short. So keep this understanding, and as we move on, we are going to use the periodic table, the sketch of the periodic table, to demonstrate this. We will be looking at the trend of atomic radius across the period and down the group. So let's quickly define the other terms, then we use the periodic table, a sketch of it, to just demonstrate all this for clearer understanding. So ionization energy is simply the energy needed, right, to remove, or the energy that an isolated gaseous atom, or simply put, it is the energy that a neutral atom needs, right, to absorb so that it will be able to discharge an electron so that it can become a cation. So that's simply the definition of ionization energy. We are going to use the periodic table to demonstrate that. Electron affinity is the energy change that results whenever an electron is being added to a neutral atom. So whenever we add an electron to a neutral atom, there is an energy change, and that is termed electron affinity. Then the last one, being metallic character, is simply the level of reactivity of a metal. So we'll be using the periodic table to demonstrate all this, so you get the depth understanding. Thank you. So this is simply a skeletal form, or a sketch of the periodic table. We will use this to demonstrate the 4 periodic properties that we have talked about. So we actually are aware that metals are rightly located at this part of the periodic table. So this part is for metals, this part is for non-metals, then we have some semi-metals here. If we exceed the 20 element, then we have the transition metals and the rest. So we are actually using a sketch of the 20th element to demonstrate all this. Now let's look at the trend of atomic radius across the period and down the group. So looking at it across the period, right, and we will looking at it down the group. Okay, so atomic radius increases down the group, right? So the group, down the group, we have group 1, group 2, group 3, and so on. So these are the periods. So the periods lie horizontally while the groups lie vertically. So vertically we have groups, horizontally we have periods. So atomic radius increases down the group. So when you are coming down from top to down, atomic radius increases. It increases. So group let's say sodium, potassium, let's just use this three to demonstrate that. So meaning that when you are coming down the group, atomic radius increases. This is simply because lithium is having how many shells? Lithium we having 2 shells, right? But sodium we having 3 shells. So let's look at it here. So lithium, first we take 2, then the second one we take just 1. Sodium, first we take 2, sodium is number 11, so the second we take 8, right? Then we are left with 1, and that will take a third shell. So it means that when you are coming down the group, there is an increase in shell. So if the shell increases, the radius too increases, right? So down the group, atomic radius increases, right? So what it means is that if we are to consider across the period, if down the group atomic radius increases, across the period we have the same number of shells. So the only thing that keeps on increasing is the number of electrons. So it means that across the period atomic radius decreases. So take note of that. Down the group atomic radius increases. So just take critical note of this, that across the period atomic radius decreases. This is simply because there is an increasing effective nuclear charge, simply because across the period there is an addition of more electrons, right? So let's say sodium, or maybe lithium and beryllium. So lithium is simply atomic number 3, then beryllium is atomic number 4, Be. So lithium, the same number of shells as beryllium 2 is having, right? So first we take 2, remainder 1, first 2, second we take 2. So you could see that they have the same number of shells, but the electrons are different. So the effective nuclear charge, right, the effective nuclear charge from the nucleus, from the atomic shell of beryllium to the nucleus is very high than lithium, which is having 3 electrons that are being pulled by the nucleus. So this is how it works. So take note of that. A result of what? Addition of more shells down the group, and across the period is as a result of increasing effective nuclear. So once you understand atomic radius very well down the group and across the period, the other three properties that we will be talking about is some are opposite to atomic radius, some are in direct proportion to atomic radius. So for example, if we want to look at electron affinity and ionization energy, now down the group atomic radius increases. So if atomic radius increases, it means that the energy that we need to remove an electron, right, from the outermost shell as we go down the group will be decreasing. It will not increase, right? It will be decreasing because down the group atomic radius will be increasing. So when the atomic radius increases, it means that the force of attraction between the valence electron and then the nucleus will be coming loose. It will be coming loose. So it means that the energy that we need to remove this electron will also be decreasing. It wouldn't increase down the group. So atomic ionization energy and electron affinity inversely proportional to atomic radius down the group. So ionization energy will increase down the group from down to top. Electron affinity to increase down the group from down to top, right? So take note. So what it means is that you have to understand atomic radius very well. That so down the group atomic radius increases, and as atomic radius increases, the number of shell down the group keeps on increasing. So as the number of shell increases, the distance between the nucleus to the outermost valence electron also increases. So if the distance is so much wide, so let's say the distance is so much wide, let's say the distance is so much wide, it means that the energy that we need to remove an electron from the outermost shell of this electron will become smaller. We need just small amounts of energy to remove electron, since the distance from the nucleus to the outermost shell is very wide. But this one, the distance from the nucleus to the outermost shell is short, so we need much energy. So it means that down the group, ionization energy and electron affinity will increase upward. It will increase upward. So it will increase upward. So take note, ionization energy and electron affinity are inversely proportional to atomic radius down the group. So let's look at them across the period. Then we look at metallic character. Then we are done for the day. So from right to left across the period, atomic radius will decreases. So it means that from left to right, moving from the left hand side to the right hand side, atomic radius will increases. So if we are to use increasing, so this is how it is going to be, and here be the starting point. So if we should start from the left hand side to the right hand side, atomic radius will increase. So atomic radius increases. But if you are starting from the right hand side to the left hand side, you should know that atomic radius decreases. Okay, so if from left to right atomic radius increases, then we know that atomic radius is inversely proportional to ionization energy and electron affinity. So it means that atomic ionization energy and electron affinity will move in the opposite direction. So just keep that in mind. Either down the group or across the period, uh, atomic radius is inversely proportional to ionization energy and electron affinity. Electron affinity and ionization energy. Take note of that. So, this being established, the final thing we have to look at is metallic character. Okay, so metallic character simply is directly proportional to atomic radius. So metallic character is directly proportional to atomic radius, whilst ionization energy and um, electron affinity are inversely proportional to atomic radius. So just keep this and I think you are good to go. So what it means is that uh, as atomic radius increases, metallic character also increases. As atomic radius decreases, metallic character also what? Decreases. And we said metallic character is simply the level of reactivity of a metal, right from the beginning. You know that sodium will be metallic, highly metallic than lithium, simply because while you calm down, atomic radius increases. So as atomic radius increases, you just need a little amount of energy to remove an electron from the outermost shell of its valence electron. So just keep these simple principles and I'm very sure you are good to go. Down the group, atomic radius increases. As atomic radius increases down the group, ionization and electron affinity will decreases, right? So across the period from left to right, if atomic radius increases, it means that from that left to right, ionization energy and electron affinity will have to decrease. It's inversely proportional. Metallic character is directly proportional to atomic radius. So if atomic radius increases down the group, metallic character will also increase down the group. If atomic radius uh, increases across the period from left to right, metallic character also increases across the period from left to right. Thank you so much.